Is Ronan Farrell, and as Dean of the Faculty of Science and Engineering, I'm delighted to welcome students, parents, and teachers from all over Ireland, and I see some from further afield, to our faculty presentations this morning. I would like to inform you that we are recording and a copy will be available later, so you can look back at what's been said. If you have any questions, please pop them into the Q&A, and there is also a live Q&A public chat taking place throughout the day, manned by our academics. Today, you will learn about the undergraduate degree offerings we have, including specialist programs ranging from robotics to statistics, biology to pharmaceutical chemistry, as well as our general science program, Mh201, which allows you to blend the different scientific disciplines together to create your own unique combinations that match your interests. Following me, from each of the areas, we have a discipline expert who will explain the course structure, the modules you'll take, and the excellent employment prospects in each area. We are proud that our students are in high demand across a wide range of industries and settings, both locally, nationally, and internationally. These are international global degrees. As a faculty, we are proud of our academics, each of which are world-class experts in their own areas. Some of whom you may have seen talking about the COVID-19 pandemic, but many others are quietly working behind the scenes on new treatments and understanding the progression of the disease, not to mention the technology that delivers us things like Zoom and Teams that enable us to work from home. As a university, we believe that excellent researchers ensure that our taught programs are always at the cutting edge of science and technology. In Maynooth, we are proud of our laboratory facilities, and it's a pity that you can't be here today to see them. We are continuing to expand and upgrade these facilities to ensure that our science and technology students get a strong foundation in the experimental aspects of our subjects. It is unfortunate that you could not be here today. The staff and our faculty are very student orientated, and we feel as a community, it is a community. We like to welcome and create this warm environment. The student experience is very important to us as we deliver a world-class education. I hope you will be able to join us in September and experience that welcome. So on that basis, I hope you enjoy our talks. Please feel free to ask any questions. And on that basis, I would like to introduce our first speaker, Dr. David Fitzpatrick from the Department of Biology.
All right, thanks very much, Ronan. I'm just going to share my screen with you now. I have a presentation that I'm going to run through about some of our offerings in the Department of Biology. Hopefully everyone can see this. So just to let you know, we have a number of different offerings in terms of degree programs in biology, and I'm going to go through these today, and I'm going to go through them quite quickly. So again, it's probably worth your while going back and having a look at some of the information that goes along with these. But if you do have any questions, just pop them in the box and I'll answer them after I've given this presentation. So in terms of our degree programs, we have a single honours BSc in biology, which has a CAO code of Mh201, and some of my other colleagues are going to be talking about this program today as well. And I think there's actually a dedicated talk about this at the very end as well, but I'll go through it briefly as well. You can also do a double honours BSc in biology. So that's biology with another subject. And again, that has the CAO code of Mh201. We have a biotechnology degree. So it's a 4-year degree program, and the code for that is Mh202. We have a BSc in Biological and Biomedical Science. That's a CAO code of Mh208. And then we also have a new degree program that we only introduced last year. So the first year students the very first year are doing this year. And that's a BSc in Biological and Geographical Sciences. And again, that has a CAO code of Mh203. So all of our degree programs are all 4 years in duration, and they're all semesterized, which means that you do, we have lectures before Christmas, then we have exams, and then after Christmas is semester 2. And again, we have lectures and then exams in May. And modularized, which means that we have individual modules. So we have modules for molecular biology, we'll have a module for maybe for ecology. So they're all kind of compartmentalized. All of these degrees, they all have an option of a final year lab-based research project. So within the department, there's 25 academics. Each academic has, and an academic is a lecturer, each lecturer has their own research lab. And in your final year, if you want, you can actually you get the option of going into one of these labs and getting a dedicated project, which you can actually work on yourself. And also, it's worth noting as well that in one of our degree programs, the BSc in Biotechnology, this has a placement option subject to availability, but basically everyone gets an opportunity to go on placement if they wish in the final year. So that's a 12-week work placement in a biotechnology related company. There are minimum entry requirements for all of these courses, and I'll mention them briefly in a second. And all of the courses are open to the here and there applicants. So these are for individuals maybe who are from disadvantaged backgrounds, or if you have a disability. So again, if you fall into that category, it might be worth your while looking up the here and there programs in Maynooth University. So I suppose the question is, well, why do you want to study biology, or why would you study biology? And if there's any parents here, I guess this is the question you might be asking your children. So what's the idea? Why should we be interested in this? Well, obviously, we can investigate the fundamental, what is life question. So by studying biology, we can track where we've come from, and how we've evolved over time, and indeed how particular different entities and even things like viruses, like COVID, for example, how it's evolving over time. It allows us to understand our bodies, tissues, and cell functions, how our cells interact with one another, how our cells interact with other external cells, again, maybe microbial cells, and how, if we come into contact maybe with things that are pathogenic to us, how our body responds to them, and is there any way that we can actually control that so that these responses don't get out of hand. It allows us to understand disease processes and help develop new therapeutic approaches. Again, because COVID is so topical at the moment, if we think about it, there's two new COVID-related antiviral drugs which will hopefully be coming out on the market soon. And again, it's our understanding of biology and how an actual virus replicates and how we can actually interfere that. We can actually develop drugs to stop that. So it's really, it's very topical, and it's very, very important, obviously. Again, we can also biology allows us to understand complexity of ecosystems. So what I mean by this is to actually have a look at particular environment and how different animals and plants and microbes interact in that ecosystem, and how we need to protect them. So again, things like deforestation, or cutting bogs, or how these sort of human impacts can have a major impact on an environment, and how maybe we're able to protect them going forward. Obviously, again, we're in what's known as a genomics revolution age at the moment. We can sequence genomes really, really easily, and by doing this, we can actually find out the genetic basis of disease. So some very, very rare diseases in different populations, by looking at genomes of individuals, we can actually see the DNA mutations in people that might cause a particular disease. And indeed, we might be able to even try to come up with some new therapies to actually help alleviate these diseases. And another really, really important aspect of biotechnology, and of biology, is food biotechnology, and the idea of how we're going to feed the planet. So at the moment, there's about 7 to 8 billion individuals on the planet. Back in 1970, there was only 3 billion of us on this planet. So it's really important that we're actually able to feed the human population on this planet. And again, using modern biology and biotechnology techniques, which we study in our degree programs here at Maynooth University, we can help to answer these questions. And obviously, again, we have, again, in our department in biology, but obviously in other departments as well, individuals are really interested in the immune system and how it interacts with microbes. So these are just, why would you study biology? Why is biology important to us? I think it's a really, really important and fundamental subject. So in the department of Maynooth, we've got 25 academics. So these are the 25 lectures that I mentioned earlier. There's me down there. And each one of these lectures has their own research lab, and they're researching many, many different aspects of biology. So just to give you an idea, I did mention that there were some minimum entry requirements. So for all of the programs You need to have a leaving certificate with maths, either an 04 or a H7, and you must also have English and Irish in either an 06 or a H7. And overall, there is a minimum requirement of 2 H5s and 4 06s or H7s. It's really important as well, if you want to study biology, and I think this is true for all of the science subjects, that you must have a science subject. So these, you must have passed one of these. So these include either agricultural science or biology or chemistry or computer science or physics with chemistry. And then what you'll see is that the individual programs, undergraduate programs that we offer, they all have different points depending on the course. And I'll just mention what these points requirements are as I go through them. So as I mentioned, Mh201 is one of the programs, and other people will cover this also. But this is if you want to do a single honors biology degree. So the points last year were 401 points. And the idea about with this degree program is that when year one, if you're doing Mh201 and you want to graduate with a biology degree, you must take mathematics and biology. And then you take 2 other subjects from one of these. So for example, you might take maths, biology, chemistry, and computer science. And as you progress through the years, you drop a subject. So when you go into year 2, now you have 3 subjects. And again, if you want to study biology, you're going to do biology and 2 other subjects. When you go into your 3rd year, you're going to take biology and 1 other subject. And if you want to do a single biology in your final year, you just take biology and don't take any other subject. So the major advantage to this is that it's very, very flexible, as in when you go into this program, perhaps you're not too sure what you want to exit with, what sort of degree you want to exit with. So by doing this, as you progress through, it gives you an idea. So actually, I should hold my hands up here. I actually progressed through this program myself about 25 years ago. So, and as I mentioned, when I would have started this program, I would have had maybe some expectation. I won't mention it, but there was a subject that I planned on doing, but I ended up graduating instead with a degree in biology. As well as that, the major advantage of this is that, again, if you do biology, there's the possibility of doing a 12-week research project in your final year. And this program as well, you have the opportunity to take critical skills and electives with this route. So very, very quickly, this is just a possible progression as an example. This is actually you might, in first year, you might take maths, biology, chemistry, and physics. Perhaps when you get into year 2, you might decide to, you're going to drop 1 subject. So maybe you've kept maths, biology, and chemistry. In 3rd year, maybe you just have biology and chemistry. And then when you go into your final year, if you're just doing the single biology, you just keep biology. Okay, so that's just one possible progression. Some people as well who enter the Mh201 program, they do a double honors. So it's the exact same idea as the single honors, except in your final year, you're taking 2 subjects. So perhaps if you really like biology and chemistry in your 4th year, you're going to take both of these subjects. And again, so the major advantage of this sort of idea is that, again, you have this sort of flexibility where you can actually choose which subjects you're going to keep as you progress through the years. And there's also research projects associated with this program as well. So in your 4th year, you get a 6-week project in biology, and you'll also have a 6-week project in your other subject. And again, there's an opportunity to take critical skills and electives with this route. So again, just to give you an idea, it's very similar to the single biology progression. It's taking 4 subjects in first year, 3 in second, and then in year 2, maybe if you were interested in biology and chemistry, and then you'd have those in 3rd year, and then you'd keep them in your 4th year. And again, you can make this decision as you progress through here. So perhaps you don't like, when you got to 2nd year, perhaps you realize you don't like biology. Maybe you might drop that and take maths and chemistry instead. But I can recommend biology. I think it's a great subject. Okay, so just now I just want to talk to you about this. So this is one of our denominated exit degrees. So this is Mh202 in biotechnology. So it's a 4-year program. The points last year were 490. And this is denominated, so there are certain subjects that you have to take in this, okay? So in year 1, you must take maths. And I should have mentioned in Mh201, the other programs I mentioned, it's essential, or you must take maths in all of our degree programs. But anyway, in biotechnology, you must take maths, biology and chemistry, and then you could have the choice of one other subject, and that's either from computer science, data science, experimental physics, or theoretical physics. In year 2, again, you must take these biotechnology, so these are set modules that you must take, and chemistry, and then again you select one subject that you would have taken in your first year. When you get into third year, you take biotechnology and chemistry. And then in your final year, you concentrate just on biotechnology. So what happens is in your final year, before Christmas, you do all of your lectures in semester 1, and then you sit your exams in January, and then after in semester 2, then you go on a 12-week work placement. So some of these placements will include, like, major pharmaceutical and biopharmaceutical companies like Pfizer, Merck, BMS, Alexion, and then also some government agencies as well. And that placement actually contributes towards your final degree mark. We also have another program, Mh201. This is Biological and Biomedical Sciences. And this is, again, 4-year program and leads to BSc in Biological and Biomedical Sciences. So the points last year were 543. Again, this is a denominated degree, so you must take certain subjects. You must take maths, biology, and biological and biomedical sciences in first year, and one other science subject or an art subject. And then it's in year 2, we kind of think of this as you're taking double biology in this, because you're taking biology, but you're also taking biological and biomedical science modules. And again, either maths or one other subject from year 1. And then in year 3 and 4, you actually have there's a huge number of modules. So if you're more interested in the biomedical side of things, you might actually take the biomedical modules, where if you're more interested maybe in ecological sort of modules, you might take the biological modules. And again, you'd have the choice to do it in 3rd and 4th year of which way you want to progress. With this project, there's an extended research project with this. So in your 4th year, you actually take a 16-week project. So it's longer than what we see for our other programs. And again, there's very specific modules and labs associated with this program. Okay, and then finally, and again, I know I'm going through very quickly on this, so apologies. And this is our biological and geographical science degrees. This is a new courses. There's only 30 places available. I actually don't have the points on this, so I'll come back with the points in a moment in the Q&A. Again, this is one of the requirements to this is an 06 or H7 in the science subject or geography. And again, because it's denominated, you must take certain subjects. So for example, in first year, you must take geography, biology, and maths, and then either data science or experimental physics. In year 2, you must take biology and geography, and then you choose between either statistics or general chemistry. And then in 3rd year, you just concentrate on biological and geographical sciences along with statistics. And in your final year, you're just taking biological and geographical sciences. So this is more directed. There's certain modules that you must take. And again, in the final year, there's research activities associated with this in terms of a research project and the possibility of a short work placement. So I suppose another thing that, again, a lot of people are interested in is, if I do a degree in biology, like, what are my employment prospects? And I think they're really, really good. At the moment, there's a huge demand for individuals, again, with the opening up of so many pharmaceutical and biopharmaceutical companies, particularly in our catchment area. There's a lot of our graduates are ending up there. We have a lot of graduates who are going into research labs, into hospital research labs, and even a biology degree. It allows you to basically tack on additional studies if you wish. So sometimes we have people maybe who've even gone into banking because maybe they had quite a computational mind. But the idea that it's a really good starting program that allows you to do additional degrees as well, for masters, for example, maybe in something that's slightly different from biology. But yeah, no, I think there's a very, very high uptake of our graduates in a lot of companies, and we see a high employment rate with our students. Okay, so I think that's everything. Apologies if I went through a little bit fast. If there's anything that was unclear at all, just please pop it up in the Q&A. and I'll do my best to address it. And for whatever reason, if anyone has any questions that you think about afterwards, and you can obviously email me directly. You'll find me on the Mh201 website. And with that, then I'm just going to pass on to my colleague in chemistry, Professor Heaney, and she is going to take over for me now when I stop sharing this screen. So Frances Heaney is up next. Thanks very much.
Thank you, David. Welcome everybody to Maynooth University and to chemistry. I'm Frances. It's a beautiful morning here on our campus, and I'm just sorry that you can't be with us to share and walk around and enjoy our lovely facilities. So this morning I'd like to tell you a little bit about chemistry and what we have to offer. So I hope you're seeing a little bit of my opening slide here from the Department of Chemistry. And what I'd like to share with you this morning is a little bit about what we do here in the department, the programs that we offer to our undergraduate students, some little bit about the research opportunities as well, for many of you may be interested in that. So what might have sparked your interest in chemistry? And the answer to that could be very different for all of you, because chemicals are everywhere. And it might be partially related to your interest in certain aspects of biology, certain aspects of the natural world and in geology, atmospheric science, for example, and indeed then in the synthetic or manufactured products. So chemicals are everywhere, and people's interest in chemicals and the chemical industry can be quite diverse. I'm going to concentrate now a little bit on the manufactured products. So what are we talking about here? And you probably are all quite aware that the chemical industry in Ireland is quite prominent. And maybe depending on where you're coming from, you may be aware of Henkel and the glues that they make over in Tala. You may be aware very much so of the booming pharmaceutical industry here in Ireland. Maybe it's the paints, for example, Colour Trend over in Selbridge. There's lots of chemical industry in Ireland, and it's dotted all around the country. Small local businesses, national businesses, and international businesses. So why might you be thinking of coming to university to study chemistry? It might be that you're interested in chemistry, you love the subject, there's something that attracts you to it. It might be that you're interested in making a contribution to the improvement of human life, maybe with new materials, new medicines, or so on. And it may be that you're interested in some research. And what I'd like to tell you is that there's a whole variety of interesting and diverse career options that you can follow after a chemistry degree course. So here you can see chemistry at the center of lots of different industries and spaces that you might like to work. Up on the top here, you can see your traditional education space. And then if you follow around in a clockwise direction, you'll see that chemists have roles in the pharmaceutical industry, in environmental science. Some chemists go into forensic science, maybe steer away from the actual chemistry, go to things like business. People are interested in material science, nanosciences, biochemistry, computational science, and so on. So chemistry can contribute to lots of different fields. As I mentioned earlier, the pharmaceutical industry is a prominent sector in this country. 13 of the top 15 companies in the world operate from Ireland, and many of the world's top medicines are manufactured here. In terms of contribution to the economy, 30 billion euro pharmaceutical exports. So it's very significant intake for the country and corporation tax. So the pharmaceutical industry has invested a lot in Ireland. It's a very important industry for us. But I suppose the message for you today is that this industry needs a lot of highly qualified and skilled people. They value the graduates from this country. They employ directly about 25,000 people and about 25,000 people indirectly. Many of those are coming into the industry with a third level qualification. And for you, if any of you are interested in chemistry, not so many people are doing chemistry, and the industry needs these science graduates. So it is a good career to be thinking about for those of you who might like to work in the pharmaceutical sector. Big drugs that are made here for the global market include things like Pfizer's cholesterol lowering Lipitor. Then there's other drugs in other areas. For example, in the arthritis area, you'll have the Johnson & Johnson Ramicad drug. You have drugs in the mental health space like Eli Lilly's antipsychotic. And again, for the bronchial diseases or sicknesses, we've got Merck Sharp and Dohme's singular asthmatic drug. In addition to those science-based or lab-based jobs in industry, there are also a selection of non-science-based roles that people might be interested in. So for example, if you go into the workplace in a science-based role, you might be in your day-to-day work involved in lab work. You might be working in product development, you might be an analytical scientist, you might be involved in validation. You may also have a science-based job, but you're not actually working at the bench or in a laboratory on a day-to-day basis. And those kind of jobs where you're carrying through your science knowledge to a professional job might include something like patent law or regulatory affairs. And then after those science-based jobs, you might notice that people who do degrees in chemistry go on to a more diverse range of employment. If you think back to that first slide where all the different employment areas, you saw business there, for example, marketing. Employers value the subject specific and the non-subject specific skills that you acquire in the training for a science degree. So that's why you see things here like marketing, sales, finance, HR, because science graduates acquire discipline specific knowledge like advanced knowledge in chemistry, but they also acquire more general knowledge, and that's what employers can value in these other sectors as well. So how might you see yourself if you go forward with a career in chemistry? And of course, young people are always interested in the remuneration and how you might get paid as a scientist working in industry. So this is just some general information that we pulled from the web. And of course, the remuneration will relate to the responsibilities that you have in your role. So there are entry points for people in the chemical industry at diploma maybe or certificate level, at degree level, at PhD level, and so on. So the responsibilities increase as you go up this chain. Diploma or certificate qualified employees tend to do some bench work and report directly to a manager. And then if you're in a BSc, you'll be working within a team. If you enter in and progress through your career in the industry with a PhD, you'll probably end up managing a team. And for these kind of roles, overall, the average salaries are of the order of about €43,000, and a typical analytical chemist may be in and around €40,000, whereas a manager might be getting significantly better paid than that. Okay, so if you're interested in chemistry and you want to come to university in Maynooth, how might you further your interest in chemistry? So I'm going to talk about 3 programs. I'm going to talk about the Mh201 program. All of my colleagues will be saying something about this today with a little bit of information on the general program and an emphasis on their own subject. So those of you who are here for David's talk a few moments ago, he would have talked on this program, focusing a little bit on what biology has to offer. I'm also going to talk about 2 specialized Maynooth programs, which are our Science with Education program and our Pharmaceutical and Biomedical Chemistry program. Okay, so if you're interested in chemistry, which of these programs should you follow? And my answer to that would be, well, it depends on what your interests are. So if, for example, you are interested in science, but you're not yet too sure which aspect of science you want to specialize in at the end, then I would recommend the Bachelor of Science program, the Mh201 program. There's quite a lot of choice in this program, and we're going to talk about it on the next slide. If, on the other hand, you are already got a very strong interest in one particular area, for example, if you know that you really like chemistry and you would like to be a teacher, well, then you might think of the science education program. Or if you think that you really like chemistry and you want, for example, to work in the pharmaceutical or chemical industry, then I would say our Mh201 program, the Pharmaceutical and Biomedical Chemistry program, is the one for you. So just to reinforce that, Bachelor of Science program allows you to explore various areas of science, and in the specialized programs, I would say if you have a strong interest in that program and a realistic grasp of what the course involves, and you're attracted to the type of employment that that particular degree leads to. Okay, so first of all, the Bachelor of Science program. Again, students are always interested straight up on what were the points. This year, 2021, the lowest entry points were 401. Previously in 2020, the lowest entry points were 360. So there's been quite a jump in the last year. So that's the current information. For students thinking of applying to this course, then the entry requirements are Irish, yes. English, yes. Maths, yes. Science, yes. Do you need a third language? No. And then the minimum ordinary level and higher level grades are recorded there, and you'll see them on the university prospectus. Important for students to know that Leaving Certificate Chemistry is not a requirement for any of our programs. The Mh201, the science program, Mh210, the pharmaceutical and biomedical chemistry program, or the science education program. We do have students in first year in all of these programs who did not take chemistry at Leaving Certificate level. Okay, so if you go in to do the Bachelor of Science degree, this is how your experience might go. So of course I have focused here on the student who would be wanting to exit with a chemistry degree. So first year, mathematics, compulsory for everybody in the science faculty in first year, and then 3 subjects of your choice from chemistry, biology, mathematical physics, experimental physics, data science, engineering science, or computer science. Obviously then if you're interested in chemistry, it would be mathematics and chemistry and 2 of the others. Second year students take 3 of those 4 subjects forward. For you, if you're interested in chemistry, it'd be chemistry plus 2 others that you had in first year, or you may select, instead of the 3rd subject, 10 credits of critical skills, or 10 credits of elective modules, or just 10 credits of the 3rd subject. And then in 3rd year, you would continue with chemistry plus 1 other subject. And 4th year, you can opt for a single major degree, which is where you study chemistry for the entirety of 4th year, or a double major degree where you study 30 credits. Each year of university is 60 credits. So a double major degree means that in 4th year, you took 30 credits of chemistry and 30 credits of your 2nd subject. So if you come into the Bachelor of Science degree and you're a first year student, what would your day-to-day or week-to-week experience be like? So for us, chemistry students have 3 lectures every week. So you'd be in the big group with all of the first year chemistry students taking lectures together. Each week you'd have a tutorial, which is of the form of independent work supported by an online drop-in centre. And each week you'd have a laboratory class, which you see here in the middle. Those are our students in first year laboratory class. To the left-hand side, you see a typical lecture theatre. This is the Callan Lecture Theatre over on the old campus. And then on the right-hand side, you'll see the students sitting their exams. So what's the assessment for a first year chemistry module? An end of semester written exam, and continuous assessment, which is made up of your lab work, practical work, and other components. If you're interested in the 2nd year elective modules and the critical skills material, you can see more about that in the prospectus, but I'm not going to talk much about that at the moment. The 2nd degree that I drew your attention to is the education degree, and the Bachelor of Science with Education. This is a degree which trains you to become a secondary school teacher of 2 subjects. So first year students in this program that are interested in chemistry will be taking the 4 core science subjects, which are physics, experimental physics, mathematics, biology, and chemistry. And then in second, third, and fourth year, these students will follow through with their education and 2 of the science subjects that they chose in first year. Again, the program is a 4-year science with education degree, and students who enter into this Mh201 program are guaranteed a place in the year 5 for the level 9 professional masters in education program. Again, you'll see more about the requirements for the Leaving Cert applicants in the prospectus. And again, just to remind you that Leaving Certificate Chemistry is not essential for entry onto this program because you're going to be doing chemistry in first year. And I'd like to talk a little bit about our specialised degree, which is the BSc in Pharmaceutical and Biomedical Chemistry. Again, Leaving Certificate in Chemistry is not essential, and the core Leaving Certificate requirements are summarised here in the slide, and you'll see them in the prospectus. What were the entry points? In 2021, the lowest entry points for this course were 510, but they were smaller in the earlier for the 2020 intake. So what is this program look like? What subjects do you study? First year is in common with the first science students in the Mh201 program. A first year student on this program, though, has less choice. In first year in this program, you will study chemistry, biology, and mathematics, and then you will study 1 subject of your choice from mathematical physics, experimental physics, or computer science. In second year, students take chemistry, they take chemical biology and mathematics. We teach the chemistry, the biologists teach the chemical biology, and the mathematicians teach the mathematics. We also have a specialised course on pharmaceutical chemistry in second year for these students, and students may select 10 credits of the elective or critical skills that we talked about earlier. In third year, students on this program focus on chemistry, biomedical chemistry, and pharmaceutical and biomedical chemistry. And then between end of third year and Christmas of fourth year, there's an opportunity for a placement or an internship. This is a competitive placement. Students go on interview to attract these placements, and they have had very positive experiences. In second year, we take our students to see around the pharmaceutical industry, and this is a photograph of one of our trips to Epsom in Blanchardstown. And then this is a little bit of more information on the work placement or internship. Students will say it gives them an invaluable experience into the pharmaceutical sector. Our hosting companies have been wide and varied, and we're very appreciative of all these companies who have hosted our students on their industrial placement. These placement or intern opportunities, we have had students located all around the country. You may see some of these companies may be in your locality, and as I said, the students have very much enjoyed them. You can see there's a selection here of pharmaceutical and materials companies, and also some of our students have had an experience in the central laboratory, in the Dublin City Laboratory. Finally, I'd like to talk a little bit about students and research opportunities. In the final year of the degree program, the science program, our students have an opportunity for a research project. And also in the university here, we have what we call a SPUR scheme, which is a student program for undergraduate research. Some students can apply and be awarded a bursary for summer research, and we host such students here in the chemistry department. And on the left-hand side of this slide, you can see our previous professor, our president, Professor Nolan, and this is an image of one of our students. Just beside Professor Nolan, there is Carolina. She was a SPUR student with us. That's me beside her, and my colleague, Ginny. We have some collaborative research, and Carolina worked with us for a summer on a spur research project, and she was lucky enough to win the poster prize, and that's Professor Nolan at the poster prize ceremony. And on the right hand side, we have David, again worked with us for a summer and did his research project with my colleague Dr. Elms, and again he was lucky enough to win a best poster prize. So I hope that I have given you a little bit of a flavour of what your experience in chemistry would be like. Here's some of our very happy, smiling graduates on their graduation day. And I thank you for listening. If you have any questions, I'd be very pleased to have a look in the chat and see what's coming up, or pop along to the Q&A facility later on. So thank you very much for your interest in Math and in chemistry. And I'm going to pass you on now to my colleague, Dr. Joe Timney from Computer Science.
Thanks very much, Francis. And I just set up my presentation now as well. There we go. Is my screen share visible there?
It is, Joe. It's starting with the BA and CS.
Oh yeah, sorry, I'm going to halfway through. Can I go back to? Okay, thank you very much. Okay, so my name is Joe Timney, and I want to welcome you to our presentation. Thanks very much, Francis, for your presentation. And I'd like to welcome you to our presentation on studying computer science at Maynooth University. So in my presentation, I'm going to talk a bit about our degrees, including the Leaving Cert subject requirements, our laboratory facilities, mention our lecturing staff and some of the research areas they're involved in, talk about our strong industry links and the career prospects, and then talk about the contact details if people want further information. So maybe the first question someone might ask themselves is, why would I want to study computer science? And the way to think about it is, if you like solving problems and inventing ways to solve problems, computer science could be for you. Also, if you like technology and you want to understand how technology works, again, computer science could be the subject you might like to do. And also then finally, if you want to play a part in creating technology for our future, well, that's what computer scientists are doing. We're working on making new technology every day, trying to make the world a better place, to make things more efficient, to make them safer, to make them more interactive, and to be able to, I suppose, manage the complex society that we live in a better way. So to give you kind of a very broad overview of what you might study in computer science is, well, you learn the practice, you learn how to program in different computing languages and for different computing systems. You learn the theory, so why are computers made the way they are? What we can and cannot compute using current technology. And you learn about applications, so how computers are used in different fields, including AI, web, databases, and audio and image processing. So it gives you a very broad overview of application areas when you go looking for a career. You can do computer science in many ways in the university, and there's many bachelor degrees that include computer science. So you can do it as part of an arts degree, as part of a BA in psychology, as part of a BA in media studies, as part of a science degree, as part of a Bsc in physics with astrophysics, as part of a Bsc in biological and biomedical sciences, a part of a Bsc in psychology, part of a Bsc in chemistry with pharmaceutical and biomedical chemistry, part of a Bsc in mathematics and computer science with education, part of a BA in finance, part of a Bsc in quantitative finance. You can take computer science through arts, Mh201, Mh202, Bsc computer science through science, and Mh203, a Bsc in computational thinking. But our primary programs, our main undergraduate CS programs, are the Bsc in Computer Science and Software Engineering, so that's, which was established in 1998, and the Bsc in Multimedia, Mobile and Web Development, which has been there since 2008. These are Mh201 and Mh202, and you can come in through an arts entry or a science entry, and I'll explain what that means in a minute. You can also do computer science as part of a BSc in science, Mh201, or a BA in arts, including computer science, which is Mh101. Or you can do a BSc in computational thinking. And this program introduces you to both computer science, mathematics, and philosophy altogether. So when I mentioned the word software engineering and I mentioned multimedia, mobile, and web development, I should really explain what those two things mean. So software engineering really is an engineering discipline concerned with all aspects of software production, from the early stages of system specification to maintaining the system after it's gone into use. So really, software engineers are concerned with building big, large, complex software systems. And what you learn in the program is how to design, plan, build, test, verify large software systems. So, most companies have large teams of software engineers, software developers working on code, and they need to synchronize that. And that's what very much the software engineer does. But multimedia, mobile, and web development is concerned with the technologies that underlie many of the computing interfaces we use nowadays. Devices such as laptops, tablets, smartphones, all along with the data types of speech, image, music, and video, and associated processing algorithms. So, when we use a smartphone, we interact with it through voice, through gesture, through image. We use it to record video. How do we process these things? And how do we interact with them? Okay, and the multimedia, mobile, web development is very much about that. If you take Mh601, so we can come into, Mh601, the BSc in computer science, see it's computer science arts, or MMWA arts entry. So you take an arts subject in your study for your first year only. It was 381 points in last year's CAO. In Mh602, the BSc in computer science for the science entry, you take a science subject in your study for your first year only, and CAO last year was 400 points. The entry requirements, here you can find them on the prospectus, but just to note maybe that you need a ordinary level 3 or a H7 in mathematics. There's also a transfer option available into this degree from the Bachelor of Arts degree, Mh101, and the Bachelor of Science degree, Mh201, subject to meeting the requirements. If you take Mh101, the computer science, you have a Bachelor of Arts degree with computer science as a subject. You take that as a subject, and it was 338 points last year. Mh201, the Bachelor of Science degree, you take, again, computer science as a subject there, and it was 401 points last year. The entry requirements for that are both here and here without going into big detail. There's no maths requirement for the arts degree, but there's for the science degree, you have an ordinary level 4 or a higher level 7. For computational thinking, basically you study computer science, mathematics, and philosophy in an accelerated 3-year Bachelor of Science degree. So the points were 520 last year. And the basic idea is to learn how to combine human creativity with the power of computers to solve problems. And you examine the essentials of theoretical computer science with their mathematical foundations. So you have an option of taking a 1-year work placement or study abroad between your 2nd and 3rd year, subject to that availability. But many students use that to take a year abroad and study in places like Barcelona or Germany. The entry requirements for this are H2 in mathematics, so they're a little bit higher. The first year then for our degrees, for Mh101 arts, you take what's CS1 as subject 1. You can take CS2, which is another computer science subject or another art subject. You take mathematics if you want to progress in computer science or some other art subject. And for your subject 4, you take another arts or a critical skills module. In Mh201, you take CS1 as subject 1, CS2 or another science subject as subject 2. You take maths, which is compulsory, and another science subject. In Mh601, you take CS1 and CS2 are compulsory, maths is compulsory too, and you have another arts critical skills. And then Mh602, you have CS1 and CS2 and maths and another science subject. Both Mh601 and 602 lead to either a BSc in computer science and software engineering or a BSc in multimedia, mobile, and web development. So you specify your choice for CSSE or MMW at the end of first year. So even if you come in one program, you can change your mind by the end of the year. You apply to transfer into CSSE MMWD from art science if you've passed first year CS1, second year semester CS2, and maths. So you should include Mh101 and Mh102, Mh201 on your CEO form. So in your first year of computer science, and these are the modules in CS1, that's computer science 1, these modules are taken by all first year students. So you have CS161 is computer programming 1, which is the Java programming language, and in semester 2 you have CS162, which is computer programming 2, which is the Java language and algorithms in Java. So normally lectures for this are on a Monday, Tuesday, and the labs are on Thursday, Friday. And the same in the second semester, CS162. If you take computer science 2, it's another 15 credits. This is compulsory for Mh601 and Mh602, but it's optional for all other degrees. So in the first semester, you take CS161, which is an introduction to computer systems 1, use the processing language, and it's 100% continuous assessment. And it's taught by 5 lecturers from the department that each introduce their own speciality area. In semester 2, then you take CS162, which is Introduction to Computer Systems, which teaches the theory of computer science. If you go if you take into your second year in your BSc in computer science and software engineering, basically you take there's 3 areas it's split into. You have programming skills, you have applications, and you have theory. So your programming skills are like algorithms and data structures 1 and 2 and software testing. Your applications are databases, software engineering, software process, web information processing, operating systems, and user experience and user interface design. And your theory then is computer architecture, theory of computation, and 2 mathematics subjects. In the second year of multimedia, mobile, and web development, you have again, it's split in a similar way with programming skills, applications, and theory, but you take the module CS261 multimedia technology instead of operating systems, and you have your maths subjects are slightly different, and you also take foundations of media design. In your third year then of these programs, you have 6 modules with specialisms related to your chosen program in the first semester, and then a 6-month placement in the second semester. And then in your fourth year, you have 1 compulsory module and the remainders are electives. And you have a final year dissertation project, which is worth 1/4 of the credits for the year. For the industry placement, we liaise very closely with the University Placement Office, and Martina Bourgeon is our placement officer that helps all the students to get their placements. Over the years, we have links with many different multinationals, national companies, and smaller startups. Places like Intel, Microsoft, EY, SAP, Workday, Revenue, Verizon, Clover, Amazon, Web Services, Oracle, General Motors, and SIG. So students are placed for 6 months, and for many students, it's a brilliant opportunity to put into practice the skills they've learned in the classroom, and also to kind of develop in terms of kind of working with other people and working with teams. It is very, very helpful for their careers later when they go looking for a job later on. Many companies will actually ask their students to come back when they graduate and work there full time. But also you have the experience of just working in a company if you want to go off and move somewhere else. If you take Mh201, the BSc, in your second year, you have 20 credits. There are 4 modules there, which are both programming and applications, and all the modules are compulsory unless computer science is a non-progression subject, and then you can have a number of electives. In your third year, again, you have modules there in computation complexity, architecture, networks, user experience, software engineering, and web information processing. And if you're doing the double major, all modules are compulsory. In your fourth year then of the BSc, you can finish with a double major or single major. So in a double major, you have 2 compulsory modules, a 5-credit dissertation project, and many electives across various application areas. In the single major, you have 2 compulsory modules, a 15-credit dissertation project, and many electives across the various areas as well. With a double major, you're sharing computer science with another subject. With a single major, you're just finishing with computer science. If you have the BA with CS as a subject, you can also do that as a double major, taking 2 subjects, 30 credits in each subject each year, equally to degree level, or you can have a major minor, specializing in 1 subject, 40 credits each year to degree level, while continuing with a smaller amount of a second subject, 20 credits in those years. to let you know about some of the supports we have with students, we have a Student Computer Science Support Center called the CSC. So this is a free tutoring service for all computer science modules taken in the first year and some for the second year. And it's both help for those that are struggling, but also advanced materials for those that want to challenge. And we found with students over the years, they come into the program with varying levels of experience with computers. We assume that people have no experience because it's the simplest way to go about it, because in some schools they do computing and other schools they don't. But for students who maybe find it a bit of a challenge in the beginning, we have lots of support there to help them through it. So there's 15 drop-in hours per week. There's online supports that are answered during the day, and one-to-one sessions can be booked then when you need them. So that really helps students that are maybe find it a bit different in the beginning. They want to be good at computers, but have a little bit of trouble. Well, there's support there to help them through that. So our facilities then, we're in the oldest building on campus. This was opened in 2015, and it's a state-of-the-art building that we share with IT services, the Campus Innovation Centre and various research centres. All the teaching labs for ourselves are on the ground floor of the building. Okay, so we have 5 software laboratories. We have 350 PC workstations, each with Windows 10 and Ubuntu. We have 16 Macintosh computers for multimedia and music technology. We have a dedicated hardware lab. We have dedicated research laboratories. And in our final year, our computer science and software engineering and multimedia, mobile and web development students all have their own workstation in the lab there. So they can install their own software and work on their own projects in that machine. That's their machine for the year. This is a photo from our teaching laboratory. So it's a 198-seater lab. We can actually split it up into 4 smaller labs using partitions, and that's the way we have it arranged at the moment. Given the current circumstances, we have a kind of a reduced number of people in each lab, but we have facilities that allows you to communicate across the labs using the multiple projector screens and audio feeds. The department organization, then we have a head and deputy head. I'm head and Tom Lysell is deputy head, and we've been there since 2018. We have over 30 lecturers in the department, all in various research areas that covers kind of a wide amount of fields in computer science. Okay, so I'll maybe say a little bit about the areas we're in. So we do software verification, which is very much about proving that software systems are going to work as they say they do. We have computer vision and robotics, which is allowing computers to see and understand scenes that are in front of them and allowing that to power robots. We have geocomputation machine learning, so using the power of computing to take information from the landscape and algorithms that will try to understand what's happening there. Computer science education, we have computing that's inspired by biological systems, optical computing, music technology, molecular computing, which is designing computer systems like molecules where information is transmitted using molecular manipulation, wireless networking, financial engineering, and smart cities and enterprise computing and immersive reality. So if you're thinking of a career in computer science, well, the average salaries for computing profession, according to New Scientist, after a number of years working, it actually outstrips many other professions. So it's quite healthy in that way. We encourage our students to apply for scholarships and get involved in competitions. And over the years, they've got many different awards between the Imagine Cup, when Microsoft was running that. We had a number of teams in that over the years. We had RoboCup. And also we've had students get Google scholarships and Intel scholarships. After, I suppose, to get some idea of how our students have performed after this year on LinkedIn, many of them posted up how they enjoyed the 4 years in Maynooth, how it had been challenging at times, but also how they were really delighted to get their degree and now look for a job. Okay. Also, that's some pictures of recent graduations, and it was great to actually have a live on-campus graduation again. Doing an analysis for graduates, most graduates of CS continue to work or research in computer science. They continue to work or research in Ireland. And of those that work abroad, the majority are international students. We have an alumni network on LinkedIn, and we do keep in touch with students there. And if students are applying for a job in a place, I'll try to put them in touch with people working in there. And we can see many of the different roles that our students are now playing in industry at the moment. Like there are senior data engineers, managers at Salesforce, evidence control manager, and data analytics, customer support engineers. Okay, so we also have lots of support within the department for incoming students, and also we have, so for our first year, we have a dedicated first year coordinator, who's Aidan Mooney, and he's there to answer questions and help students all through the year. As you move up in the years, then we have a coordinator for the second to fourth years of computer science and software engineering, which is Charles, and for the multimedia, mobile and web development, which is Tom. And then for any of the other programs for science, it's Dermot Kelly. So if you have any further questions, you can contact us by phone at the number there, or you can contact computerscience.department@mu.ie, or follow us on Twitter, or look at our webpage. Okay, thank you. And I'm available to take any questions in public if you have them. So now I'll pass you on.
Thanks, Joe. That was great. For anyone who has just joined us recently, we're running slightly behind. So our next talk is on electronic engineering. So that's Andrew. And if you're good to go, Andrew, and please feel free to ask any Q&As or questions in our Q&A box there, and we have the academics available to answer. So hand over to you, Andrew. Thank you.
Good afternoon, everybody. Thanks very much. Yeah, just let me get my screen up here now so we can start with this. You're all very welcome to this today. I hope everybody can see my screen there.
Yeah, that's good, Andrew. If you want to just put it on slideshow.
Yeah, from the beginning there. Resume slideshow. Hopefully that has gone. Nope. Has that gone up correctly now?
No, it hasn't.
No, it hasn't. Joy. Okay, we'll go. Come on. Okay, that's a pain. This was working earlier on. It's wonderful. So if anything is going to go wrong, it always goes wrong at the worst possible time for me. Let me just see what I can do here.
Yeah, and it's fine, Andrew. We can see your slides. So if it can't go from slideshow, we can see your notes now.
Yeah, there we go. Is that a bit better? Anyways, look, I'll go on because we are a little bit behind time. It doesn't really matter if you're going to see the notes. I'll be talking around them. We are a little bit behind time. So as Ida said, my name is Andrew Meehan. I represent the Electronic Engineering Department this afternoon at this presentation. I'm just going to tell you about the major programs that the EE department are involved in, run through a little bit of the details on those. And of course, I'll be on the public later on, or stick your questions into the chat function. So the Electronic Engineering Department is involved in three major degrees: the Electronic Engineering degree, which is Mh204, which I'll speak about in a minute, and also Mh306, which is our Robotics and Intelligent Devices program, and finally Mh201, which is our Engineering Science program, where you can do electronic engineering through an entry in science. So really, what's electronic engineering about? So our electronic engineering program, the direct entry program, has two major exits on it. One is a 4-year BE degree, which is accredited by Engineers Ireland, or you can choose to do an ME, a master's, which is an extra year, which is accredited by Engineers Ireland as well. If you choose to do the MA, you graduate with both a BE degree and a master's degree. And the reason that I mentioned the accreditation part by Engineers Ireland is that if you wish to become an accredited professional chartered engineer, the ME, the master's qualification, is now that minimum requirement. Like many of the other courses that I've been on previously to me this morning, we offer work experience. For the BE degree, your work experience would be in 3rd year, and if you choose to do your 5th year, your master's, that work experience will be in 4th year. And that's industrial work experience, which is a competitive process, or you can choose to go abroad in an Erasmus project, or you can choose to do a research project within the university itself. So as people always ask, code is Mh304. CA points are about 360 to over 400, depending on demand in each individual year. Now, I should point out for direct entry to the electronic engineering program 304, you need a H4 or better in maths, along with the standard other entry requirements, including a science subject. Now, we do have a specialist maths exam that's on for people who don't do higher level maths. A bit early to be talking about that now, but the details of it are on our webpage. So really, why would you want to do electronic engineering? Well, I'm going to flick onto this slide, and this slide might give it to you, because we are everywhere. Without electronic engineering, no mobile phones, no computers, so no computer science, no advanced technology, no analytical tools. So basically, without electronic engineering, you know, our universe, our world as we know, would grind to a halt. Not only are we just in the obvious things like computers and toys, we're in some less obvious things like your microwave. I would hope that nobody currently on the program has a pacemaker, but clearly electronics is a very important part of pacemakers, and modern cars these days are just covered in electronics. And then we are involved in things like control systems that deal with regulating and maintaining a lot of the production plants. In fact, pretty much every production plant that produces all the things in the world. So we are, you know, very, very essential. On top of that, we're part of that whole wave of making new products and improving things. I always like this slide because most of the younger people who are probably on these nice touch phones that are very, very colorful, while most of the lecturing staff are on, probably have had or owned most of the mobile phones towards the left, these big brick ones. When some of us remember the joy of having a watch that also doubled as a calculator, you know, way, way back in the day. So we really are at the forefront of changing all these type of things. So we kind of sit very neatly as engineers in between some of our colleagues who do the pure science, who are really on the discovery side of the world, and technicians who we really need in order to implement some of the discoveries. And we're kind of sitting in between, and we're almost like the meat and the sandwich, so that we design through various means technologies to get the discovered idea into something that's useful and implementable in everyday life. So we spend a lot of times creating things within the department, even though many engineers wouldn't deem themselves to be creative people. We do use a lot of creativity to solve problems. So why do you want to come to us? You know, there's a lot of good reasons to study electronic engineering in Maynooth. We've quite relatively small class numbers, which is good. It means we get to know the students quite quickly. It also means that it's easier for the students to get to know us. Because we have slightly smaller numbers and because we have our own dedicated PC and hardware labs, it means you have better access to facilities. And we also have quite a nice mix of international students, which is very good for developing some of your soft skills and dealing with people on a one-to-one basis. Now, one of the things that makes it a little bit unusual compared to other universities is we tend to use a lot of what we call problem-based learning, or PBL learning. So every year from first year right up into your final years, we'll put you into groups of people. We will assign you a problem, a fairly ill-defined problem, and we'll have you work as a team to try and solve that problem. And really here, what we're looking forward to see is we're developing your ability to solve a problem, defend the work that you've done, and to work in teams, because you're not going to be able to do things on your own. And when you go out into the workplace, you work in teams, you don't work on your own. So there's a bit of a change from the kind of traditional type of lecturing that happens in a lot of other places. So while you do have a lot of hours as an electronic engineer, you have quite a large lecture lab and tutorial load. We do offer a lot of other social activities because, you know, you got to have a bit of fun too. So we have organizing quiz nights. We tend to have a lot of staff versus student competitions, soccer, basketball, pool, depending on what's going on in the university. Obviously, that's been a little bit curtailed over a little while. I'll put it out there and say that the staff are quite good at winning stuff. A bit of experience over youth there. We have a very good engineering society that's run by the students, which is great. So the students teach themselves and teach other engineering students programming skills, building skills, soldering skills, and it's a fabulous way for you to reinforce your learnings. The lecturing staff are pretty nice. We're a fairly chilled out bunch. We like to have our students engage with stuff. you know, we're good at cracking jokes and we're not too adverse to having a good time. We have some very, very good lab facilities with very good PC access as well. We have, you know, 1, 2, 3, we have about 9 different labs worth of material that we can use for students. And we use a lot of the kind of industrial grade programming language. So we'll do Python, MATLAB, C++, to name a few, because this is what's used in the electronic industries to get things done. As I mentioned before, we do work experience. Both the 4th years and 5th years for the electronic engineering program do work experience. And also if you choose to do the robotics and intelligent devices program, which I'll talk about in a minute, you get work experience in 3rd year there. And we also offer, once you're up in kind of 4th year, 5th year, opportunities for you to partake in teaching labs as tutors for 1st years, which is a great way to pass on your knowledge, because you know you have the direct experience of being a 1st year, understanding what it's like, and we pay you for that. So it's a nice little bit of work experience for you there. So what am I going to get out of it? Well, loads, right? So a lot of people do researchers, people do PhDs, people do masters. We do a lot on the mobile phone technology side. We do a lot on the ocean energy and control system sides. So renewable energy is a very, very big side, and typically then we end up in a lot of engineering companies, the Intels, the Googles, Pfizers, etc., all employ electronic engineers as a matter of course. Some of the more successful students have managed to get up and work in NASA and the ESA quite a lot. Quite a number of our PhD students end up actually in financial services and financial trading environments because of the way that we teach the course. One of the key things about engineers and scientists in general is that we teach you to absorb a lot of different types of information and come up with a solution. So it's one of those things, because of the way that we teach you, it's quite much easier for you as an engineer, once you're finished as a primary degree as an engineer, to learn something like economics. Much more difficult to teach somebody who has done economics or business problem solving and engineering techniques. Now, I would say, again, I'll point it out again, because both degrees, the electronic engineering 4-year degree and the electronic engineering master's degree, are accredited by Engineers Ireland, it means that they're internationally recognized automatically. So for people who want to travel and use their degree abroad, it's a much, much easier prospect than having a non-accredited degree. Now, of course, all of the details of this are up on the webpage. If you look for the Electronic Engineering Department on the main menu page, you'll find our general contact details and mine specifically. So if you have questions on either of the EE degrees, please do contact me in one of those ways. Now, I'd like to talk a little bit more about our kind of the second program that we're involved quite heavily in, and this is Mh201, our Bachelor of Science degree in Robotics and Intelligent Devices. So this is quite an interesting one in terms of, really, it's quite an interesting blend of electronic engineering, which is the kind of hardware and digital logic, analog logic side, and computer science. And really what we focus on here is the intelligence of physical objects within our environment, what we can do with sensor networks to tell us something smart. Pardon me. Again, you would have the opportunity to do a workplace within this program, and you tend to do a lot of projects within the program so you can show different aspects of your skills. Typically 360 up to about 400 points again for this type of course. You need the standard entry requirements, English, Irish, maths, a science subject. However, you don't need the mandatory H4 and higher level maths to get into this program. There is an ability to transfer between the Robotics and Intelligent Devices program into electronic engineering if that's what you prefer as well. So typically the type of things that you're going to be involved in, these are just some of them. We deal quite a lot with medical technology now. So a lot of people will be wearing smart watches like Fitbits or Garmin's that deal with the heart rate and blood pressure, etc. as well as more advanced medical devices. We deal a lot with home systems that are smart. They make a decision based on information that they have. Ovens or adaptive heating, various types of security systems, even something as simple as you would think as simple as your kettle. And of course, then the usual toys that talk back to you and respond in a pseudo-intelligent way to questions that you ask it. And then obviously robotics and intelligent devices. So we deal more on the robotics side as well. And so we deal with the new up and coming social and domestic robots. You can see this here, that the orange fella here is actually called a neo robot that we play soccer with, or I should more correctly say, we program it to play soccer. We deal with interactive robots in terms of helping people around the home, which is becoming more and more of an issue. We also deal with some kind of light industry style robots, servers and that kind of stuff, as well as autonomous vehicles and drones. So there's a huge amount in there that people who do the robotics and intelligent devices program will do. Now, so how does it work? Just give you a quick overview on that. You would typically, deal with all of these things on the list. So intelligence really to everyday objects. So can you tell a kettle that it's getting too hot and let it deal with it itself, as opposed to you having to switch it off all the time? Can you tell a heating system that it's wasting fuel because it's heating too high based on the temperature outside and inside your house? And these seem like slightly small and silly things, but really quite important in the overall scheme of things. And we strive then to teach you the software and hardware skills for you to do that. This slide kind of typically gives an overview of what you might do in your 4 years. Like many of the engineering programs, the 4th year is probably the most important, where you'll be doing quite a lot, quite a large project that spans both semesters. Okay. So if you're somebody who likes to make things or combining various aspects of things to make something new, this probably is a good fit for you. If you have an interest in how humans interact on a daily basis with technology and how you might improve that interaction, it probably is the course for you. Pardon me 1 second. Excuse me, a little bit of a fog in my throat. So in terms of what you need to have coming in, maths is a great tool for us. We'll teach you all your maths. We have a math support center that's available to everybody, but a reasonable skill in maths would be useful for you. And then physics is always a good one for us, although it's not a mandatory requirement. Physics is a good one for both the electronic engineering programs and the RIS program. Sorry about that. That should have gone back to that slide. And then some sort of interest in computers and programming would be good. All right. So really, I suppose looking forward to your careers, we're moving into this kind of whole prosthetics and medical technology side, assisted living for the elderly, because as our population ages, we're going to have to make use more and more of technology to help people who are living on their own. Okay. So sorry, just checking the time here. So I'm just going to flick through here. So typically you gain employment in just about any style of engineering, any style of medical company quite easily. The robotics industry is quite small at the moment, but it's getting bigger and bigger and bigger. So those are going to be key areas for you. Okay, so just then to mention the last program that we have, because I'm quite aware of the time, is we have a program called Engineering Science, Mh201, where you can do electronic engineering through the science program. I think Ita's going to talk more about the 201 program in detail a bit later on. All right, so engineering science, you can take electronic engineering as an option in the 201 course. So you can choose to do a single honors in EE, so you can move into the pure EE or ME electronic engineering courses that I talked about earlier on, or you can continue through your science degree with the electronic engineering and do either a single or double honors major in that course. And I'll speak to a little bit more detail to that down in a few pages. Typically, the point CAO is about 350 to 400 again. You can see all of the detailed requirements for that course in the prospectus. And again, because you're going to be doing electronic engineering subjects within the EE department, you would be exposed to this problem-based learning methodology that we use quite a lot of. So this slide here gives you the various paths of exit that you have. So you can come in your first year and do your EE modules plus your standard 201 courses. You can move into second year and continue on the science thread, the BSc science thread, or move into the either Bachelor of Engineering or Master of Engineering, Electronic Engineering program, if that's what you desire. All right. Now, there are some criteria on this if you want to transfer out of the Mh201 module into something else, and they're detailed here, but you can speak to us a little bit more in detail once you get into the department and if this is what you choose to do. Okay, so typically these are for those people who have decided that they don't want to be a pure scientist and they don't want to be a pure engineer. They sit somewhere in the middle of the two. So you have a lovely set of job opportunities in that crossover between the two. A lot of those would be as follows here. So people that move a lot into things like laser and photonic systems. They deal a lot with wireless networks and radio systems, which is quite important to us with the use of mobile phones. And they tend to move a lot into the development of new materials for the electronic sectors. I suppose the flexible screens would be the newest thing, the new foldable screens that will come out for some of the phones in the last couple of years would be quite a big one for there. And I'd probably leave you with this slide today, which is quite poignant. We always feel that art without engineering is dreaming, and engineering without art is just calculating. So we do a lot of creating in all of our courses. So if you like to solve problems, if you like to make new things, this is probably the course for you. Okay, folks, I'm going to stop there and stop sharing and let my colleague get on to maths and stats. So Doctors Singerland and O'Sullivan are going to be talking about physics and theoretical physics in the university. I hope that was useful, and I'll be on the chat function later on. Thank you very much. Bye.
Hi, Kriya. It's to welcome you. Sorry, I'll hand straight over.
Okay, hello everyone. My name is Kriya O'Sullivan and I'm in the Department of Experimental Physics. So you're going to hear two talks about physics subjects now. So there's two physics subjects in Maynooth. I'm going to talk about experimental physics. And my colleague, Dr. Jo Slingerland, is going to talk about mathematical physics after that. So let me just share my screen. If I could check maybe whether my first slide is visible there.
Yep.
Yeah, all good.
Great. Okay, thank you very much. So, so you're going to hear about two physics subjects that we do in Maynooth, and I'm going to just start by mentioning the Mh201 Bsc degree, because you can study these subjects as part of that. So that is the sort of the flagship science degree that we do in Maynooth. And you'll see there two of the subjects, mathematical physics and experimental physics, among a range of others. Now, some people talk about Mh201 as being general science and other degrees as being specialized. I'd like to emphasize that if you do Mh201 science degree, you don't come out with general science. You come out with a BSc in mathematical physics or a BSc in experimental physics or a BSc in biology or chemistry and so on. So this degree is as specialized as every other degree. The difference is that you don't have to decide what you're going to specialize in at the very start. You make your decisions as you go along. And if you want to study experimental physics or mathematical physics, you can do it as part of this degree. So you don't have to say from the start that that's what you want to do, but you pick these subjects and keep them as you go along. But I do want to emphasize that you end up as specialized as every other degree. And so it's ideal if you're not 100% sure of what subject you do want to specialize in, or maybe you're not sure if you want to take 2 or more subjects in your final year. So this is the structure of the Mh201 degree. It's 4-3-2-1 if you want to specialize in one subject. So you see at the end there, you do come out with one particular degree subject. Everybody must take maths in first year, but then you have a choice of other subjects. And you don't have to make your decisions before you need to. You make them as you go along, and you end up specializing in the end in one of the subjects you took in first year. So it's an excellent way to study science, particularly if you're interested in more than one area and you're not quite sure. Many people think this is the way all degrees should be. Don't make your decisions until you have to. There's no advantage or disadvantage between denominated degrees coming in with an aim already, or the undenominated science degree. So the only difference is some people may know already at the start what they want to specialize in and might want to have their subject choice listed out for them, or there may be subjects where there are limited number of spaces, and yet you have to know from the start how many people are going to end up in it. In my 20 years in Maynooth, we've never turned away a physics student who's capable because of space. So it hasn't been an issue for us. So you can take experimental physics or mathematical physics this way, have it as one of your subjects in first year, and keep it till the end. And of course, if you love physics, you can do both subjects and keep them both till the end, if you don't want to make a decision between them. And as physicists, we obviously think this is a great option. So that's just talking about the degree structure in general. So it's 4-3-2-2 or 4-3-2-1, and you don't have to make the decision until you need to as you go along, but you will end up specialized. You've heard already about possibilities of taking elective modules in second year. Again, so you have a few options in this degree that you may not have in the denominated degrees. Okay, so I'm going to talk to you first about one of the physics subjects. I'm going to talk about experimental physics, and the other degree option that's run by the Department of Experimental Physics, and that's physics with astrophysics. So experimental physics is studied as part of Mh201. So you come into Mh201 if you want to specialize in experimental physics, and physics with astrophysics is one of these denominated degrees. So it's named from the start. This is the single honor structure. So if you want to do experimental physics, you take it as one of your first year subjects. You have to take maths. You can take 2 others. You've seen the range of subjects we have. There are certain combinations that aren't allowed just because of timetabling. So it's always worth checking that out before you make final decisions. But it's got a very good range of choice if you want to take experimental physics as one of your subjects. We would recommend that you would keep maths or mathematical physics as you go along. It's very useful to have with experimental physics, although you don't have to. So we do leave the options open. So that's the single honor structure. If you do physics with astrophysics, it follows very much the same path. So a physics astrophysics degree is about 1/3 astrophysics, about 2/3 core physics. And again, it's this 4-3-2-1 structure. You can also take double honors if you take experimental physics. So you can take it with a second subject and keep both of them in your final year. This can allow for some, maybe more unusual subject choices, like maybe experimental physics and biology. So if you're interested in work in the area of medical physics, some of our graduates have gone on to work in maybe oncology departments in hospitals, where having both physics and biology is very useful. And that's not a subject option allowed in very many universities. So it's something sort of unique about this degree option in Maynooth, is that you can tailor it to your particular interests. So if you want to take experimental physics as part of the Mh201 degree, you don't have to tell us at the start that that's what you're going to end up with. If you want physics or astrophysics, it is a denominated degree. It's called Mh204, and you make that decision at the start. If you want to have a look and say, well, what would it look like if you came here to study these subjects? The structure means that each of the subjects in first year, every week you'd have 3 lectures, 1 tutorial, and a 2-hour lab. So sometimes when you think of experimental physics, we don't just mean the experiments. It's like physics in school, rather than say applied maths, which maybe mathematical physics would look like in first year. So we do experiments, but we also do theory, we do lectures. So you'd have about 3 lectures a week, you'd have a tutorial, and you'd have a laboratory. So we can think, testing our theories in the laboratory is an important part of our subject. And like every other subject, of course, there's a lot of self-directed study. So you have to be self-motivated, but there's a lot more freedom than you would have had in school. These are the kind of topics you would study if you did physics or experimental physics. Some of them you would recognize if you've done physics in school, and you don't have to do physics in school. So we have about half our class in first year would have done physics before, and half wouldn't. Some of the topics are what you wouldn't have maybe seen before: quantum mechanics, computational physics. There's also things like environmental physics, nuclear physics. So very exciting areas of physics, and we study all these topics as part of experimental physics. And we try to understand nature. So really all aspects here are covered in these topics. Our degrees are accredited by what's called the Institute of Physics, which is the professional body for physicists. And they make sure that all our degrees, both experimental physics and physics astrophysics, cover all the core areas of physics. So you can be a chartered physicist, you can be a physicist. So if you do physics astrophysics, it doesn't mean you have to be an astronomer. You can work in any area of physics. We just think it's an interesting way to learn physics. And the Institute of Physics makes sure of that. And they also make sure we teach you ancillary skills like writing reports and group work and presentation skills and all those other things that employers will expect you to have these days. As well as the lectures and the laboratories, when you get into final year, you work on projects. You probably work with a member of staff more closely, maybe in their own research area. We also bring students on field trips during your degree. So maybe visit some industries or maybe a physics department in a hospital. We also bring our astrophysics students to a professional observatory in France. So physics, you may be familiar if you've done physics in school with some of the topics. Astrophysics perhaps less so. So I want to just give a few slides about the astrophysics degree and the kind of things you might study in astrophysics. In astrophysics, we want to understand the objects in the universe, and we also want to understand the universe itself, the dynamics of the universe. And to do that, you're looking at very faint signals, things that are very, very far away. And so we very often have to develop the relevant technology to make our observations, to study these objects. So we build and design scientific instruments as well. So they're not the kind of instruments you can buy off the shelf. And we also make observations. And you have to learn to do all those things in an astrophysics degree. So there's theory, but there's also some very applied topics related to developing the technology needed to make these. And again, I'll just emphasize the point that you will be a physicist after this degree, and you can go into any area of physics afterwards. You're not restricted to being an astrophysicist or an astronomer. Just some pictures from my first year slides, just to give you an idea of the kind of things that you would study in astrophysics. On the bottom left there, you see our sun, and it's very important to understand the sun these days and the energy output from the sun. We're going to increasingly, I suppose, capture more and more energy from the sun. And we also want to study climate change, how much of that is due to the changing sun. You can see in this image that the sun it's not just a bright point in the sky. There's a lot of stuff happening on the sun. We need to know about solar weather. It affects our communications. So we want to understand our sun, but also other stars. And stars don't stay the same forever. They're born in gas clouds. Some of you may recognize the Orion Nebula there, the pink one picture towards the center, where we can see new stars newly forming from this big gas cloud. On the top left, we can see dusty disks around some of these young stars. And now we know that there's planets around so many of the stars in our universe, and we want to study those planets. We study the planets in our own solar system as well. We study the life of stars then after that. So they turn into middle-aged stars like our own sun, but they eventually run out of fuel and they die. And in the middle on the right there, you see what will happen to our sun when it dies. It'll turn into what's called a planetary nebula. The outer layers of the stars are a star has gone off into space, and you might notice a tiny white dot in the center called a white dwarf. That's what's going to happen to our sun. If our sun is a bit bigger, it would end its life in a supernova explosion, like shown on the bottom right of this slide. And we study all those things when we study astrophysics. That's where chemicals are made. So the carbon that we're made of, oxygen and so on, are made inside stars. Most of the universe after the Big Bang was hydrogen and helium, about 3/4 hydrogen. All the heavy elements were made inside stars and then scattered around the universe in these supernova explosions. And the next stars and planets that formed from those. So when people say we're made of stardust, that's what they mean. We study not just stars, but collections of stars. In the top left there, you see our neighbor galaxy called the Andromedan Nebula. If you're got good eyesight, this is often said to be the furthest thing you can see with the naked eye. You'll see a little fuzzy blob in the sky. This is what our galaxy, our Milky Way, would look like if we were from the outside, 100 billion stars. You might notice they're different colors. Some of them are kind of blue. In the center, it looks more red. We study why that is, young stars, old stars. And of course, they're the things that we see with our eyes. Our eyes are tuned to pick up stars because our own sun is a star, and it helps us to navigate. And our eyes have evolved to look at the light from the sun. But if we look at the universe with different kinds of light, so not just optical light that we see with our eyes, but radio waves, X-rays, gamma rays, we see all different aspects of the universe. On the right there, the red and blue picture, the blue is what you pick up with an optical telescope. The red is what you pick up with a radio telescope. You see these jets coming from the center of the galaxy. There's a supermassive black hole in there, and that's what's causing those red jets. Same at the bottom left there, that greeny picture is a radio image of a galaxy. It looks completely different in radio waves. So we study all those, the technology and also the scientific information you can get. In the center, there's a picture that's of interest to us in the experimental physics department. We work on something called the cosmic microwave background radiation. So we design experiments to look at this radiation that's left over from the Big Bang. So it's like a baby picture of the universe. Of course, with astronomy, because it takes light time to travel, the further away you look, the further back in time you're looking. You know, we see the sun as it was 8 minutes ago. Look further and further away, you look further and further back in time. We can look back almost to the Big Bang in that picture. On the bottom right, it just shows an experiment that we were involved in at the South Pole, which is a nice place to do astronomy. It's cold. It's got a very dry atmosphere. But we've also worked on space experiments with the European Space Agency as well. And all of these are aspects that you would study if you came to Maynooth to do physics, astrophysics. We take our students on field trips. So you see here talking to a former member of the department who has worked in the European Space Agency, showing students around. We also take our students to an observatory in Haute-Provence in France. Unfortunately, we couldn't with COVID, but we hope to start those again. And the students get a chance to make observations with professional telescopes, and then they take their data back and they work on that for their project in the final year. And one of the students made a very nice video of the field trip to Haute-Provence, and that's the address there in the center, and there'll be links to that from our page. This is an idea of some of the jobs that you can get with physics. So this was from a publication, the Institute of Physics, where they just interviewed Irish physicists and asked them about a day in their life. So these are all jobs that people have in Ireland with a physics degree. So there's a huge range of jobs. And the Institute of Physics, if you look at their website, have a nice career section to give you an idea of the kind of jobs that you can get. So there's a huge range of, I think, very interesting jobs that you can get with a physics degree. And that's whether it's experimental physics or astrophysics or mathematical physics, the same applies. You can do all these jobs. A lot of employers are interested in your problem-solving techniques, your ability in the laboratory, your ability to handle difficult abstract concepts. I will just mention that we do also have the science education degree, so you can choose if you want to become a secondary school teacher to have experimental physics as one of your subjects. So you'll be able to teach physics in secondary school if you want to do that. So this section isn't specifically to talk about that degree, but just to mention that it is an option, and physics teachers are very much sought after now in secondary schools. So I leave it there for experimental physics. I'd be very happy to answer any of your questions either now, or you can contact or email me at any time. Be very happy to talk to anyone who's got individual questions. So I'll hand over now to my colleague from theoretical physics, who's going to talk about other physics subjects that you can do in Maynooth. So hopefully you can share there, Joost.
Thanks, Clay. Okay, I'm just sharing my screen. Okay, so can everyone see this first slide?
Yes.
Well, thanks, Clay, very much for introducing physics as a subject. So I will now try and give you some information more specifically about theoretical physics, but before saying anything, I will say that there is really no strict boundary between experimental and theoretical physics. So in reality, many physicists that consider themselves theoretical physicists would also be closely involved with experiments, and similarly, people who are actually building instruments could be excellent theorists at the same time. And so for a rounded physicist, the best situation is obviously to have a background, at least to some extent, in both areas. Now, what about theoretical physics? So first, maybe before I say anything more, I should say that in the university, many of the modules that are taught by theoretical physics department are called mathematical physics. So don't let yourself be confused. These are actually attached to the theoretical physics department. Of course, there's a reason why there's this confusion, because theoretical physicists tend to use a lot of mathematics. So what is theoretical physics? Well, it says here facetiously, physics without the labs. But this is maybe something that you can take into account if you are coming, for example, into our general science degree that's Carrie introduced, where you have 4 subjects. You may have a lot of subjects involving labs, and then theoretical physics is a subject where we have a lot of tutorials and problem solving, but we don't actually have labs, which can be quite useful sometimes, particularly in situations where there's a pandemic and you can't come in physically. Let's hope that doesn't happen again. Anyway, a lot of the flavor of the theoretical physics we offer, say in the first year, is sort of similar to leaving cert applied math. So if you've taken applied math and you enjoyed that, then you're very likely to also enjoy theoretical physics. But if you haven't, it's obviously not a barrier at all. And in fact, you don't even have to have taken physics. A lot of our students come in with no physics whatsoever, and we just take it from the start. So what is the difference between a theoretical and an experimental physicist? Subject to what I just said about that they are not really completely separate, but experimentalists are of course interested in finding out what the world is like. They do experiments, they find out new data, and then of course you want to understand somehow how you can explain this data, how you can explain these experiments. And so theorists are often involved very much in building models for the universe, or building models for materials, or building models for anything physical that you can observe. Of course, if the data that you observe cannot be easily explained, then you're thinking about new models, often in a sort of speculative and creative way. So you can think about how should the universe be like, or if the universe was different, how would it do things differently? What would an alternative universe look like? So various things that theoretical physicists are involved in studying are, well, quantum physics, physics of the very small, which happens, for example, between elementary particles. So then we arrive at particle physicists, or in materials where we have many elementary particles interacting with each other and having some rather unusual collective effects at very low temperatures, for example. Then, of course, gravitation and cosmology are an important part of theoretical physics. Understanding gravitation at the level of just planets in the sun, or at the level of galaxies, or at the level of the entire universe. That's where you get to the cosmology. Meteorology and the climate are, of course, very important, especially currently with all the climate emergency. And that requires you to understand a lot of fluid mechanics, thermal physics, how does the heat of the sun get distributed through the atmosphere, etc. And then the interesting thing is that a lot of the mathematics that plays a role in theoretical physics can also be used for all kinds of other modeling, for example, chaos theory and financial modeling. So a fair number of our graduates actually end up with banks and insurance companies because they've learned useful skills that can also be used for modeling the financial markets, or modeling the survival of your insured customers. And then there's all kinds of interesting materials physics, for example, superconductivity, where materials conduct electricity without any electrical resistance, is explained by some beautiful quantum mechanics, quantum physics. Okay, So what kind of things can you then actually study in Maynooth? Let me give you a sort of overview what happens if you enter and go through first, second, third, and fourth year. So in first year, we really start with the basics, which is Newtonian mechanics. So we introduce the concepts of forces between different objects, for example, gravitational force, where they attract each other through gravity, and we describe motion with velocity and acceleration, etc. And then we also give you some idea of how these traditional ways of thinking have been modified then over the centuries after Newton, introducing special relativity and some quantum physics. Then in second year, we actually start thinking about thermal physics and statistical physics, which are important for describing any kind of materials or things or large physical systems with many components, and where heat, for example, plays a role. We also introduce electricity and magnetism, clearly essential for example for this talk, where you wouldn't be seeing anything. Vibrations and waves, we see them all around us. Also essential for this talk, you wouldn't be hearing me without any sound waves. And of course, there's a lot of mathematical methods that have to be introduced as we make our description of the universe more and more sophisticated. Then in third year, we spend a lot of time on quantum mechanics and computational physics. So quantum mechanics is a major component of third year, and again more mathematical methods, of course, play a role there as well. And then in the fourth year, there's a whole plethora of different courses going into different specialized directions. For example, you can go into particle physics and think about the kind of stuff that happens at CERN, the big particle collider in Switzerland, or you can go into quantum information, thinking about the future of computers, how they can use quantum mechanics to do equations, to do calculations faster and model materials, for example, solid state physics, fluid mechanics. There's all kinds of things. Okay, so just to give you a flavor, so in first year, we'd be talking about gravity, for example, at the level where we say, oh, there's two objects and the objects are attracting each other with these forces, which are indicated with the blue arrows. So they have a size and a direction, and the direction is just from one object to the other. And the size is given by this formula. And the formula involves the masses of the two objects. And the distance, you see it's inversely proportional to the distance squared. And this constant, Newton's constant. And this you can actually use to, for example, understand the motions of the planets around the sun. So when Newton discovered this was an amazing discovery because, people have been studying the planets for millennia, and suddenly it could be explained how they moved by this very simple rule that everything attracts each other, not just the planets, but the sun. In fact, all masses attract each other in this way. So it was a great discovery. Once you get to our fourth year, we have upped the level of sophistication where we can think about, for example, black holes. And here's a picture of a blackboard that actually comes from a live online lecture from our department, Peter Coles, from from last year, where you see a horizon with a black hole going down the center. These cones here on the edge of the horizon show you what happens if a light beam is trying to be sent out from this point here. And you see that all the rays of light are actually staying inside the horizon, so nothing can come out. That's why it's called a black hole. And there's many other interesting features that you can describe here once you have enough maths that's not on this board. For example, you can show that despite the fact that no light can escape a black hole, nevertheless, the presence of a black hole creates radiation, which is the similar radiation that would be generated by an object with this particular temperature, the Hawking temperature. So there's lots of, you can go from the lowest level of sophistication, two masses with forces between them, to a very high level of sophistication where you can think about black holes and all the phenomena and quantum phenomena around them. I have another slide here with some interesting phenomenon. This is a fountain. That doesn't sound very spectacular, but this fountain actually drives itself. There's no pump driving this fountain. This is an interesting quantum effect that happens in certain types of liquids, liquid helium at very low temperatures in particular. And this fountain will just keep going forever, and is an example of something that can happen in a superfluid. Here we have an equation describing superfluids, which actually we here. And the superfluid has a property that, for example, if you had some superfluid in a cup here and it was rotating, it would rotate forever. And people have actually done experiments like this where you can see it rotating for days and days and it doesn't slow down. And this is a collective effect of all the particles sort of in the fluid moving together in the same quantum state. Okay, so then enough about trying to make you enthusiastic for wonderful theoretical physics. What are your career opportunities? It's an incredibly, because of the modeling skills and the sort of abstract level that you learn here, there's actually a lot of opportunities. So a lot of companies are interested in the kind of skills that you end up with. So in Ireland, of course, you can go only into research and university, and actually more than 40% of our graduates go into postgraduate studies. You can, of course, teach in secondary schools. And then there are many IT companies, especially if you're good with computers as well. They're very interested in our graduates because of their modeling skills for various programming tasks. And also in the financial services, there's a lot of employment there, again, because many financial decisions are improved by modeling. But actually, there are lots of other areas that you can go into as well. For example, telecommunications, aerospace, medical physics is a big one, which Crea talked about. Actually, a really big one also is the new energy revolution, the alternative, the solar energy and wind energy is all based on physics. For example, solar energy is driven by solar cells, which are only we were only able to make because we understood quantum mechanics of materials well enough. And of course, the future of computing is also very much a research area in theoretical physics. Then we can just go back briefly to what are the possible degree programs here. So you can take theoretical physics through science, through the general science degree. And in that case, what you see is that you have this typical program with 4 subjects in first year. You have to take, of course, mathematical physics, which is theoretical physics, and mathematics. And we, of course, would certainly, if you're really interested in physics, you should also take experimental physics. It's a very complementary set of modules in the first year, and you get a much more rounded idea of what it is to be a physicist. But of course, if you're taking some other subjects and you feel like I have all these chemistry and biology labs already, for example, then mathematical physics is a great option to add, just to get the flavor of what is all this underlying theory behind the universe and forces and all that materials. Okay, so well, this is the usual structure. So in going to second year, you drop one of your subjects, hopefully not mathematical physics, and then in going to third year, you drop another subject. And then in fourth year, you can choose whether you keep 2 subjects and get a double major, or you keep only mathematical physics, and then you have a single major. Do not require higher level physics to enter our degrees. I saw that somebody asked that in the right. So then we also have a denominated degree, which is theoretical physics and maths. So if you, for example, did a lot of physics and applied maths in school already, and you were really good at it and enjoyed it, then this is probably a good option for you because it allows you to enter our degree at a more advanced level. So skipping some of the material that we teach in first year, which is more geared to people who do not have that experience yet. And it will allow you to then graduate with almost as much theoretical physics background as somebody who would take the full 4-year degree. So this degree is only 3 years and allows you to get to a skill level that's comparable to the 4-year single honors degree. And of course, you take half of your degree in mathematics. So you obviously have to like mathematics a lot to take this also. So you end up with mathematics and theoretical physics half and half in each of the 3 years of this degree. If you think this is a little bit too much, but you still want to take the 3 years with the half and half theoretical physics and maths, you know that's the direction you're interested in. You can also just enter into our first year, and then we have an option that if you do well enough in your first year, you can actually enter the the theoretical physics and math stream then afterwards and end up with the same type of overall education. And then you have the advantage that, for example, in first year, you can then take experimental physics as one of your subjects. So you actually also have some background with the more practical side of physics. Okay. You can also take mathematical physics through arts, which is unusual for a science subject, I guess. So, for example, because we don't have labs, maybe, if you are doing German literature or music technology or whatever you like, you can take mathematical physics as one of your courses in first year. And in fact, you can keep mathematical physics all the way through. If it turns out that you're really into it, you can, for example, take your 3-year maths degree with mathematical physics as one of your subjects in first year, and then just keeping it all the way through to final year. You can't take it as single honors, but you can get a long way to that, because you can even take it as a major with minor, with a major in mathematical physics through arts. If you're planning on doing this, you should really be aware that there's quite a good level of math skill required to take mathematical physics to the end. So, but you'll probably find out pretty soon in your first year if it is for you. And we have had students go through this with some success, and some of our most interesting students go this way. So, so there are many other degrees that include some mathematical physics, but you can't take it all to the end. So, for example, if you want to take physics with astrophysics, then you will take some mathematical physics in your first and second year, but in final year, you probably will not take any mathematical physics. Also, mathematics education, computer science, and software engineering, and biotechnology all includes the possibility of having some mathematical physics. And finally, I would like to say that we are quite a research-focused department, so we always offer the summer program for undergraduate research, so research projects in the summer that the university offers, but we actually go beyond that and we offer our own additional studentships for summer research, which we also fund. So you can take these during the summer and not miss out on an income from your summer job. And also, if you take a single honors degree, we have a research project as a mandatory part of that, in fact. So you will always have some kind of research experience by the time you exit our degrees. So if you have any questions, you can of course use the online Q&A, or if you want to think about it a bit or get a more detailed answer, then please just email me or our head of department if it's more sort of, can I do this degree with this kind of question. And thanks very much for listening, everyone. I think I should give the floor to the next person, who is...
It's Raphael, so that'd be great if Raphael could share his screen now too.
Yep.
Apologies for those who are listening. Raphael's going to give a presentation, and then I will finish off the webinar with Mh201. I know we're slightly behind, so hopefully you can stay on to listen to myself and Raphael. Thanks, Raphael.
Thank you. Can you see my screen?
Yep, we can, Raphael.
Perfect. Thank you very much. Hello. Good afternoon and welcome to this open day. And I'm going to talk to you a little bit about our maths, stats, and data science programs here at Maynooth University. Okay. So there you go. So first of all, why mathematics or why statistics, right? I think I can say, and probably everybody can agree with me, that a basic proficiency in maths is pretty much essential in the modern world. Like everything we do, we are surrounded by applications of both mathematics and statistics. Every decision that we make is somewhat based on some latent calculation of a probability in our own heads, whether it's going to work or not, and then we act on it. But it's very good to actually make informed decisions. So we make decisions based on maths and stats. And last but not least, each and every one of us, we have a very nice, very good problem-solving skills. So our brains have evolved in such a way that allows us to think in abstract ways and solve problems. And I have just one quick example here of how maths and stats can help you make sense of the world and make decisions. So imagine here for this particular toothpaste that nobody knows which one it is because I've concealed it. It says 9 out of 10 dentists who tried would recommend. Well, okay, but what do you mean with that? How many dentists did you survey? It says here that they surveyed in April 2011, 77 dentists. Are they all dentists who are friends of the people who are producing this toothpaste? Where are they based? What sort of skills are they proficient in? These are 9 out of 10 who tried. What about those who didn't try, and so on? So this is definitely, of course, a marketing campaign trying to say, look, if 9 out of 10 would recommend it, so you might as well use it too. But then it doesn't say whether they recommend any other toothpaste as well. So we need to be a little bit critical whenever we see these types of things. And we are bombarded by this every day. So I'm a statistician. So my background is actually in biology. And then I work now with statistics. And I can tell you a couple of reasons why I like statistics. And maybe you will resonate with some of those reasons. So one of them is, if I could actually summarize those reasons, is that I think that statisticians pretty much have some sort of superpower, because we are able to use data and get conclusions and make decisions and so on to maximize whatever we want to gain or to achieve what we want to achieve, our goals, etc. And we can actually use it to predict the future, which sounds pretty magical to me. So for example, if you have one of those in your phone, or if you have checked on Google or anywhere the weather forecast, there's stats, there's data science, there's maths involved behind it. We look at patterns in the world and try to use current patterns or patterns from yesterday, today, to predict what's going to happen tomorrow. So we can use some very cool mechanistic and statistical models to predict that. And not only can we say, well, it's going to be 5 degrees, but we can also measure the uncertainty. It's going to be 5, but we are 95% confident it's going to be between 2 and 7. And that's way more valuable than just saying 5 and then getting it wrong. In scientific research, so if you intend to become a scientist, you're definitely going to need statistics and maths. You're definitely going to need data science, because if you want to make sense of your data, if you want to test hypotheses, you're going to need to gather data, and you're going to need to know how to work with it. In the insurance market, I don't know if you've ever taken an insurance, or if you're starting to learn how to drive, or if you have to take an insurance and pay a premium, right? How do they calculate that? They take all of your data and they fit it, they feed it to a statistical model, and then that model is going to tell them the probability that they're going to have to pay for an accident or for something that might happen and you might need to claim. And that's going to help them calculate how much you need to pay for your premium. So there's stats and data science involved in that. In the stock market, if everybody knew how much GameStop was going to go up earlier this year, everybody would have bought GameStop stock. So that's where stats and data science come into play. We try to see the behavior of the stock market and predict what's going to happen tomorrow and the next day and so on, to help guide our decision making in terms of, do we buy stock, do we sell stock, and so on. In medicine, and this is very timely because of the COVID-19 pandemic, everybody who's had a vaccine, or there has been extensive research about those vaccines, where we have something that we call case control trials and so on. So every time you take a pill, there's been extensive statistical studies behind it to actually make sure that that pill is going to do what it's intended to do. That's going to heal you. That's not going to kill you, and so on. In quality control, so in different companies and in different industries, where I need to do quality control and see whether they're producing a particular part the correct way and so on, and assessing how machines are working, et cetera, et cetera, et cetera. There's plenty of other reasons, and I'm going to talk a bit about some others throughout our conversation today. But of course, I maybe would like to say that a cool reason why study statistics or data science, because you can predict the future pretty much. And not only can you predict the future, you can actually imbue it with some uncertainty level, and you can explain the uncertainty to others. So what is mathematics? Okay, I'd like to start with this question. What is mathematics? Well, whatever it is, we find it everywhere. Okay, and there's a friend of mine from the Department of Mathematics and Stats, Mark Walsh. He likes to say that mathematics is interesting because of basically three different things. One is because of the curiosity that drives mathematicians, that drives the development of mathematics. Second, because of the intrinsic beauty of mathematics. Mathematics is beautiful. I have maybe a couple of examples here, for example, in geometry or in art, right? And also because of practical need, because we need mathematics to make sense of the world. When we started counting, how much stuff do we have, and so on. So whatever mathematics is, we find it everywhere. So in art, for example, and here I have a particular example of the Alhambra in Granada, Spain. And if you study maths in Maynooth, you're gonna see objects like this and study these properties in different modules. Another example here of art in the Book of Kells, which you definitely have heard of, symmetry and so on. We find it in nature, and this actually appeals to me and with my biology background. I really like the idea that you can describe natural phenomena using maths. So this is a nautilus shell, and it follows a principle, this particular spiral, it follows a nice principle, which is the Fibonacci sequence. And that's a sequence of numbers that you get, and you can reach a constant that we call the golden ratio. And that's cool because the golden ratio appears everywhere. It appears in pine cones, in nautilus shells. It appears in proportions in the human body. It also appears in macro proportions, as in galaxy spirals. So we can find it everywhere. And to me, that's fascinating. It appears in music. For those of you who like music, like I do, it's also very, very mathematical to explain music phenomena and harmonics and so on. In architecture, if you're interested in architecture. And data, of course, is everywhere. So here in the left, I have a map of Ireland. So Joost was talking about climate change in Crea as well. And imagine if the sea level is going up and we have the worst projections for the next 100 years, this is what the map of Ireland would look like. So the sea level would have gone. So this is for the worst projection. Just a quirky fact here, even at the worst projection, Maynooth wouldn't be underwater. So you can come to Maynooth, that'll be fine. Here on the top right, I have something that appeals to me because I really like applications of stats and data science to ecology. This is the Sumatran rhino. There are fewer than 90 individuals, 90 individuals in the world at the moment. So they're in the brink of extinction. And we can use stats applied to ecology and wildlife management to try and turn the situation around. Here's another example that I was working with during my PhD years ago. So this is a bald eagle in Alaska. So this photo was taken by an amateur photographer kayaking near Prince William Sound, and then he depicted a bald eagle trying to feed on a seagull. Bald eagles typically feed on fish. They will attack other birds in the case of lack of resources. So in this case, definitely there was some environmental disturbance going on there. And then another seagull was trying to peck the bald eagle from above to maybe save its friend in a phenomenon that I affectionately nicknamed as the bird sandwich, but definitely not a type of bird sandwich you'd like to see, because this is reflecting some environmental disturbance. And of course, we are in the age of big data, if you've heard of the buzzword big data before. So this is what happens every 60 seconds in social media or online. So look, more than about 90,000 hours of Netflix. I think that this has gone way on 9, because this was taken in 2018. And now after the lockdowns, everybody pretty much watched every Netflix video that was there. 700,000 hours of videos watched every minute. 1 million photos shared on WhatsApp every minute. One of my favorites here, more than 1 million swipes on Tinder, but only 18,000 matches. So persevere. The probability is kind of small anyway. But yes, can you imagine all of these companies? They need data scientists. They need statisticians. They need mathematicians to make sense of all of their data. They need them. They need us. And it's our duty here in Maynooth to train you to be able to deal with large data sets and to be able to make sense of them and extract insight. So a little bit about the programs that we offer here in Maynooth. In terms of maths, we offer quite a lot of programs. So we have the pure and applied maths via general science. So that's a 4-year program via Mh201. Anita is going to talk about Mh201 in a few minutes. We have the one that Joost just commented on, that's BSc Theoretical Physics and Maths. So that's a 3-year program. We also have math studies through a BA, that's 3Mh101, that lasts for 3 years as well. We have a nice program here, which is called BSc Computational Thinking. It lasts 3 years. It's Mh603, and that includes maths, computer science, and philosophy. And if you're interested in being a teacher as well, or interested in education, we also have the BSc Maths Ed. So that's Mh212, so you can also take maths and education. In terms of stats and data science, we have a BSc denominated entry data science that I'm calling it new. Well, it's actually the 3rd year that we're running at the moment. So if you decide to join us, you'll be in the 4th cohort. And updated programs in statistics. So we also have a BSc statistics and the BA in statistics as well. So available through these two routes. And also, if you're an omnibus science student, you can take data science in year one. No matter what other subjects you would like to take later, you can still take data science in year one. And I'll talk a little bit about that in a second, okay? So what is stats? What is data science? Well, basically we have data that can be numbers, that can be names, that can be locations, that can be images. That's also data. And then we do something, step 2, a black box here, and we have knowledge. So basically stats and data science will come into this black box, and it's our duty here in Mh201 to teach you how to actually transform data into knowledge. And what will this involve? This will involve manipulating the data. You have to change something from row to column, transpose, etc., filter, etc., manipulate the data, or data wrangling, as we like to call it. Visualize it. We are visual creatures. The first thing that you do when you have a list of numbers in front of you, you make a plot. If I could give you 3 tips for being a good statistician, data science right now, would be number 1, make a plot. Number 2, make a plot. Number 3, make another plot. We are visual. This is how we work. And finally, you model it. But this is a cycle, okay? After you model, then you get some more data, you visualize it again, you model it again, and so on. So statisticians, data scientists, they're pretty complete scientists, in my opinion, because they need knowledge in statistics and the theory and the backgrounds and the techniques that you can use. You also you need knowledge in mathematics, because all statistical techniques are based on mathematical tools, and you need knowledge on that as well. And you need knowledge in computer science, because you need to be able to tell the computer what to do and how to do what you want it to do. And so you also need skills in programming. But none of this would matter if you also don't have skills in communication, because you can have the stats, you can have this computer science skills, the programming skills, the math skills, but if you can't tell people, your stakeholders, what you produced and what they want to know, then it's all for nothing. Here in Mh201, our programs are designed to teach you stats, computer science, maths, programming, and communication. That's very important. Where can you work? Well, you can work for any company or institution or university that deals with data. And as you can tell, there are loads, okay? You can work in actuaries. This is a cool one, forensic statistician. You're kind of computing probabilities of somebody having committed a crime or not, or are also based on DNA samples as well, which is pretty cool. An environmental statistician, something more akin to what I do. I like to look at the environment and animals and wildlife and try to see what's going on and how can we manage wildlife for to maximize yield or make it sustainable and so on. You can work for the government. You can work as a medical statistician. You can work for pharmaceutical companies, sports. I got friends working in sports and trying to predict which ways they can train the team to make it maximize their potential and so on. You can work as a school teacher. You can do market research. You can do anything that uses data. So how does the denominated entry BSc Data Science would look like in Mh201? In first year, you would take data science, computer science, maths, plus another subject of your liking. Second year, you continue on with stats, CS, and maths. Then in years 3 and 4, you continue with stats and computer science, plus some specialist data science modules, which include industry guest lectures. So you're already in touch and have this network of industry members where you can go to after you finish, and also a capstone course. And for those of you who are taking science but wouldn't like to do stats or data science, the subject of data science is also available to you in first year, okay? So you can take maths, 2 others, and data science if you would like. And this, even if you don't want to do statistics or data science or maths, you would still learn the basics of how to manipulate, visualize, and report or communicate your data. And these are valuable skills for any scientist across the board, because every scientist will work with data, will work generating hypotheses, and they need to know how to analyze it or how to understand an analysis and how to report on it. And if you actually like it, in year 2, you may continue on by taking statistics, and then you can do the BSc Stats or Data Science through Mh201. So why choose Mh201 for a science degree? Well, this option of data science in year 1 in a science degree is a unique feature of science degrees all across Ireland. And as I've said, all scientists collect data and want to make sense of it. So having even basic skills to manipulate data, visualize it, report on it will definitely improve your employability after graduation, will make you a different scientist. Thank you very much for your time, and I'm happy to take any questions. Thank you very much.
Thanks Thanks a million, Raphael. And there are questions coming in. There's a question there on the data science one. I can follow it up if you can't find the information on it. Thanks to everyone who is submitting questions. My name is Mh201. I'm going to talk very briefly on Mh201 because many of our academics have covered it. Let me share my screen. But please feel free, and thank you, Kate, and everyone else who has asked questions so far. Kate has followed up with an email to me directly. So that's the first thing I want to tell everyone. If you take nothing away from my presentation, is I would advise you to take my email address. So if you have a question later today, next month, next year, or before the 1st of July, a change of mind deadline, feel free to drop me an email, ita.mcguigan@mu.ie. Get a pen and a bit of paper, write that email address down, and send me a question on anything to do with STEM at Maynooth or in Maynooth in general, and I will find out the answer for you. So I'm happy for you to take my email address and contact me at any stage. I'm here briefly to talk about Mh201. I'm conscious that there's another arts seminar or webinar kicking off very, very shortly. So maybe students who are still on this want to join that, so I won't delay you. As I say, many of the academics from across the various departments have already explained Mh201 outline for you. So hopefully you will get, have already received lots of information from that. You will know that the CEO entry requirements for 2021 was 401. I would like to highlight, and there has been a couple of questions on what are science subjects that we will accept for entry into Mh201. So I've put them up on the slide there. Some people have asked that in the Q&A session. There is no language requirement for Mh201, so you don't need a foreign language. And if you have an Irish exemption, people have been asking, will we accept an Irish exemption? Sure, we will, but make sure it's from the NUI on Merrion Square that you have applied to for your Irish exemption. And that's true for all courses in Maynooth, that we accept the Irish language entry requirement exemption, apart from, let's say, for primary school teaching or something like that. It's also important to note, if you don't get the points, or I know many students come into Maynooth who may have received the points for Mh201, but do want to take a year out and possibly go and do a QQI qualification, just to reaffirm in their mind that yes, science is something they want to do. Or possibly you go and do the PLC route or the QQI route because you don't have the entry requirements, so you don't have the CEO points required. So we do accept the QQI entry requirements, and we've great information on the website on that. Again, if you can't find the information, drop me a wee email and I'll be happy to send you on that link. So it may be of interest to people who possibly want to take the year out or who haven't achieved the basic entry requirements. And many of our students come in and succeed in Mh201 coming through that route. Why people always say to me, Ita, why would you encourage someone to do Mh201? I always say it's your degree, it's your future, your choice. Mh201 offers such flexibility that many other courses do not offer. You have to choose maths in year one, and some people think, oh no, I don't want to do the maths, and other people think, brilliant, I want to do maths. But actually one of our leading academics in the maths and stats department, and I'll mention her briefly, Dr. Niamh Cahill, she has a PhD in statistics, and I said, oh, how did you fall in love with maths? And she says, well, Ita, I done Mh201 in Maynooth University. I had to do maths in first year, fully expecting to drop it in second year, but she said she fell in love with it. So, you know, come in with that open mind. What's really good about Mh201 is you can sample all the subjects in year that are available, the other 7 subjects, and you've got 4 weeks to decide. So you might come in saying, okay, well, I have Leaving Cert Biology, I have Leaving Cert Chemistry, so I might as well do chemistry, biology. I might pick physics because I've heard of physics before and I have to do maths. But I would really encourage you to try all the subjects that are on offer, from data science to engineering science, and you've got the 4 weeks to decide. I'm not sure where my list has gone. People always say to me, what can I work at when I come out of Mh201? Because, you know, people say, and Creya actually mentioned earlier, you know, it is correct that it is a general science course. However, as Creya said, you're a specialist in those subjects. So these are just some of the list of the courses of where our graduates, what they're doing now, where they're working, and what their job title is. So you know, it's a great course to suit your needs and to get you into the career that you want to go into. So this is where I was looking for this list earlier. It was supposed to come before that last one. So yes, you pick the maths in first year and you pick 3 from these other subjects: biology, chemistry, computer science, data science, engineering science, experimental physics, and mathematical physics. Now, as I said to you, you might think, okay, I'm going to go in and do chemistry, maths, and physics and biology because that's all the subjects that I've ever done in school and that's all I know. As I say, make an informed decision. And as I said at the very start, this is your degree, shape your future and pick the subjects that really suit you. Imagine if you hadn't went into engineering science during those first 4 weeks. You're not making an informed decision if you don't go in and try them out. You could find out actually you love engineering science and you could transfer into year 2 electronic engineering. Or you might say data science. Wow, if I combine the biology or data science and look at how COVID is tracked around the world, it really might open your eyes onto or spark an interest in you. So use those 4 weeks wisely. So the important thing is check out the prospectus for any slight subject combinations that mightn't be possible. But so in first year, pick your maths and the 3 other science subjects. In second year, continue with 3 of those subjects, and there is an option in second year for a 10-credit elective. Again, check the prospectus. Or the critical skills, again, check the prospectus for that. And in year 2, you continue with 2 of those subjects, as many of the academics have outlined already. And in year 4, continue with 2 or 1 of those subjects. Do not worry about what you're going to be doing in 4th year right now. So, you know, don't even worry about what you're going to be doing in 2nd year. And as I said, even when you come in first year, you've got 4 weeks to try it all out. So, you know, concentrate on your leaving cert this year. Or if you're in 6th year, concentrate on making an informed decision on your CEO. And we're all here to help in any way that we can if you need further explanation or if we need to provide you with any more information about STEM at Maynooth University. There's lots of great information on the website. The yellow arrow at the top will show you how someone in the chat box asked what exactly will I be studying in 3rd year of chemistry. So this is an example of how you find out that data from the website. Again, drop me an email if you can't find this. So in course structure here, you'll be able to see, for this example, I just clicked on data science and then details below explain in detail what you're going to be studying. This is breakdown on, you know, the credits. So in first year, each of the 4 subjects is equally weighted, and then subsequent years, that's a breakdown of what is the weighted of each subjects in that. What's the best way for you? Back to what I said a couple of minutes ago, don't worry about 4th year or 3rd year right now. Don't worry, you know, make an informed decision on your CEO. Another good thing about Mh201, many people come into it because it offers the flexibility and the subject combination that other courses don't offer them. So it is their number 1 choice in their CEO. Other people might say, okay, I possibly want to do, say, I'm going to pull an example here, biological and biomedical sciences, say, as number 1. But whatever happens on the day, maybe you don't get the points that are required. Some people use Mh201 to come in hoping to transfer into year 2 of one of the denominated degrees. But actually, do you know what we find? We find out many of the people that come into Mh201 who thought they wanted to apply for a transfer into year 2 of a denominated degree, they're actually that happy in Mh201, and they've actually used those 4 weeks to try out different subjects that actually now they've actually changed their mind on what subjects they're going to specialize in. So many stay in Mh201 because of that change of mind in the first 4 weeks that it offers them. But rest assured, there is that transfer option. However, please check the prospectus. It is a competitive process. You know, it will go on your year 1 Mh201 results, and you will have particular subjects that you will need to have taken in year 1. Again, send me an email after this. Check the website if you want any more information on that. We have lots of excellent student ambassadors who are available on the platform here, MU Ask a Student. That's available not just an open day. So even tomorrow, the next day or whatever, if you think of another question and you don't want to talk to Ita because she's an employee of Maynooth, possibly you want to talk to Andrea because she's a year 2 student of science that you're thinking of, and she will be able to tell you what it's like studying science as a science student at Maynooth University. So use that function. Remember what I said to you at the start, make a really, as much as possible, informed decision on your CEO. So talk to our students. We have many graduates all around the world. These are a couple of events that I just want to highlight that are taking place in January and February next year. So we're having the Department of Chemistry are running an event, and it's for Leaving Cert Chemistry and Biology students. More information on our website. But also, as Raphael mentioned there, from Maths and Stats, this is Neve, who I talked to you, that is now one of our lecturers in Maths and Statistics, who came into Mh201 hoping to drop Maths in year 2, and this is her job now is a lecturer. So there's a couple of different events that we're running throughout the year for Leaving Cert students back to help you to make that informed decision. Again, more details on our website, or drop me an email if you can't find this anywhere. That was a very quick whistle blow tour of Mh201. I apologize I ran through it in very quickly. I was conscious that we were over time, conscious that people might want to get to the arts talks now. I've given you my email address. I'm just going to put it back up there. So anyone who is hanging on and wants to run off and get a pen and a bit of paper, that's my email address. Happy to liaise with other academics that maybe you have a question for them. And if I can help any student in their CEO decision, and I suppose anything to do with Maynooth University, please do not hesitate to contact me. I'm going to check out the Q&A in the box. Just a lot of people are asking for the recording of this, and we will send the link when we have all the open day presentations and webinars uploaded. So thank you very much for everyone coming along today. My name is Ita. Thanks to all the academics who presented today, and we look forward to hearing from you in the near future. Don't hesitate to contact us or contact the students. My goodness, this is the first time I'm saying I hope everyone has a happy Christmas. So take care everyone, and thank you, and join the arts talk if you wish now. Thank you.